How's the drive? It's okay.
So we are online, and
So, hello everyone. Welcome to Essence of Science podcast. My name is Misha.
and I'm Dr. Abbasi, and we are missing our trio today. We are missing Amanda. Hi, Amanda.
So today it's going to be a nerd talk, like just both.
Yeah, we can
both
call
of
it
us.
nerd talk, or you can call it the most fundamental part of existence. We are going to talk about Poincare recurrence theorem, and you chose that subject. And I was a little, I should say, Misha, I was a little surprised you choosing that subject. So tell me, why did you choose this subject for our podcast today?
I have my master's degree in artificial intelligence, and probability theory is a big part of it.
Mm-hmm.
So that recurs to me that this theorem perfectly describes like what a world could be given from a probability perspective, like how things are rearranged and returned to any default state. Like you can define what default is. So it triggers my thought on what afterlives can be like, or like what reincarnation might look like. And this provides a theoretical explanation of how reincarnation could work.
Well, that is actually a very interesting subject, and I know it has many interpretations, but we agree that Poincare was not a theologian. He was not a priest or a religious person at all. This theorem initially wasn't really made for any metaphysical thing. What do you know about the history of Poincare and Boltzmann theorem? What do you know about practically these are the birthing place and the evolution of the most important theory in the entire world, which is thermodynamics. So what do you know about the background of Poincare and how this theory, how he came up with this theory?
Well, not a lot. I know something about the Poincare conjecture, which does it relate to that?
Yeah, they're all related. They're all related. Now let's juice it up. Have you heard of Boltzmann demon?
A little, but not enough to explain.
What is a Okay.
It's a person.
No, it's not a person.
Boltzmann is a person.
Boltzmann is a person. Boltzmann is a person, certainly. And all these people have had really colorful story. Now, to really understand this theorem, you have to go way back. There is two thoughts about the whole universe. One is the steady state universe, meaning that universe is there, is not changing. And then there is this ever-changing theory of universe. As a matter of fact, Einstein was thinking on the steady state of the universe, that universe is there and is never changed. When he found out that there is something is not in his formula, not adding up, that what he found that is not adding up, he had to compensate for that, for his formula to add up. It's called cosmological constant. If you add that, without that, Einstein formulas don't work. If you add that, it works. But Einstein found that that means universe is changing. So for that reason, he called that his biggest blunder. Literally, he called that constant that he has to add for his formula to work his biggest blunder. Now we know that was his largest triumph, meaning that constant is because the universe is changing, that the vacuum does have an energy level. And all of that comes to that the universe is ever changing. Now, later we accepted that. Now we know universe is not a steady state universe. It's an ever-changing universe. And then something very interesting happened.
Like, what do you mean by ever changing? The what property of the universe is ever changing?
Space is expanding.
You mean the boundaries?
Space is expanding and the universe is cooling. In few Google years, the atom will fall apart. Everything have a half-life. Now, you know about the radioactive material, right?
Yes.
You know they have a half-life, right?
Yes.
What is the half-life of like uranium and so on?
It's like their mass reduced in half in a certain period of time. And
certain molecule, certain atom, in certain time, half of that falls apart.
What do you mean by falls apart? Where do they go?
Well, like uranium,
Yep.
that gives you helium and other atom, and then change into lead.
Oh.
As a matter of fact, all the lead today on Earth is there because it was more uranium which fell apart. The radioactive, not every uranium, uranium 235, not uranium 237. It falls apart, it gives you other atom, including helium, and then you have lead. And as a matter of fact, that's the only reason we have helium on the Earth.
It's because of uranium.
Uranium falls apart, gives you helium and
lead.
Like,
okay.
That is why helium is a very
stable.
Well, no, helium is stable, but it is a non-replenishable. There's only certain amount of helium because when helium comes to the air, it's so light, it goes out of the Earth, and it with the solar, the radiation, it just escapes the Earth. The only reason we have helium on Earth is from the oil wells, where uranium falls apart, create helium and lead, and so we have both. That is a radioactive, but we know that about radioactive material because they fall apart so much faster. Like uranium is 300 years or something like that. But every single atom in the universe has a half-life. But that just half-life is so long that literally it doesn't really matter to us, like trillions of years and so on. And
Can you say that again? Every what?
Like every atom that we consider
every
stable,
atom has a half-life.
Absolutely.
So
this is the so-called the Heisenberg uncertainty theory, that means that everything can be in many states, and that eventually will happen. Some atoms, like some atom, they fall apart within millisecond. Some atom, like uranium, fall apart within a few 100,000 years. But at the end of the day, every piece of matter eventually changes. What that means, many, many years in the future, like hundreds of Google years in the future, it's so-called the theory of cold universe. Meaning that everything, it falls apart. There's really nothing, there will be nothing in the universe. Everything will be just, space will expand as it is doing now. Now, it is interesting though, how we found out about that the space is expanding. Do you know how we know space is expanding?
Blue shift or red shift?
Well, the shift. Let's just call it the shift, okay? But
we found that things are moving away from us.
Do you know who found about that?
Hubble telescope?
No, Hubble, yeah, very good actually. Hubble found out that he was looking at distant galaxies. He saw that there is a shift in the hydrogen, in the light of those galaxies. And that galaxy, through the shift in that, he found out how far they are going away or coming toward us. What he was surprised is that every galaxy he looked, it's going away from us. There was not there were only few galaxies that they come to us, but the 99% of the galaxies, they were moving, especially those that are further, are moving faster away from us. Now, reverse that clock now. Reverse that clock. What does that mean? That you go now in the past, meaning everything was closer and closer and closer. And you go the clock back 13.7 billion years, then you got the Big Bang, where all the matter of the universe was in one place. So you remember we talked about the steady state universe?
Yes.
And now that's not true. And then now we are talking about ever-changing universe. And then all of a sudden, we have a beginning of the universe and we have an end of the universe. The end is like very, very far in the future. We have the 13.7 billion year in the past, but the future is unimaginably far away, but there is an end.
So you support the idea that the universe is expanding, but it will contract again.
No, I didn't say that. I just say that based on the current understanding that we have, based on the measurement of the expansion of the universe was at a certain point in single point.
Yeah.
And in far, far future, universes will be so vast, so big, that it'll be really nothing there. Everything, every atom will fall apart. Even the black hole will be the last remnant of the universe, and nobody could imagine that the black hole will fall apart, except the famous Stephen Hawking found out the Hawking radiation. The Hawking radiation is when a black hole just at the event horizon, again, based on Heisenberg uncertainty phenomenon or theory, this virtual material come to existence. And this virtual material that come to existence, the part that's closer to the event horizon falls in the black hole, the other part goes away. The part that falls in the black hole has a negative mass. So eventually, even if we call that black hole evaporation, even black holes are going to evaporate and bloop, they will be gone. Eventually, again, in unfathomable amount of time in the future, nothing, it will be all nothing except space. There'll be a space. It will be just space. Now,
is it going to be heated?
No, that is a good question. The temperature of the universe was like unimaginably high at the beginning. Eventually, it became like 5,000 Kelvin, which is about 10,000 Fahrenheit, And then at that point, light starts, and when it cooled down more, light starts escaping. We can actually measure that. It's so-called the infrared background radiation. If we look far back in the past or far enough, we see this glow of at that time when the entire universe was 5,000 Kelvin. At that point, everything is plasma. Light cannot accept that. As a matter of fact, that is a wall. We cannot look behind it. Okay? Why am I saying all of that? Is because for a long time we thought universe has a beginning, Big Bang, and universe have an end. They call it Big Chill. Big Bang and Big Chill. Now, what you are talking about, the Poincare recurrence theorem, it says this wasn't the beginning, or the interpretation of that. Poincare brought that theorem long before all this we talked about. But his theory has been used to go the next step, that yes, everything is changing, but it's cyclic. It is not, Big Bang wasn't the beginning and Big Chill is not the end. So there is no beginning and no end. It's eternal, forever, like pi, never ends. So what is the characteristic of the pi? Let's talk about that, and then I tell you where we are going.
So it never ends. It consists all possible combination of anything you can think of.
Like your life story is in pi.
Yep. If I encode my life story into 26 English characters and label them, and I'm sure this is in pi somewhere.
In pi.
Yep.
Everything has ever happened and will ever happen is in pi.
Yep.
Because pi doesn't end. Everything, your life story is not only once in pi.
Yeah, infinite amount of times in pi.
life story is infinite amount of time in pi.
So is everyone else's life.
So is every life. Your DNA is in pi.
Yeah.
And so everybody else's. Now, your DNA is not only once in pi, is
Infinite
amount of time in pi. Now, the universe cannot be old enough for you to go and look for it in pi, because we know just the first 26 billion or something of pi. That is by far not enough to really say anything, but pi is random. It never ends. That is mathematically proven that everything that can ever exist, if you code it, will be in pi. Yeah, we agree on that?
I agree on that. I also agree it exists in other irrational numbers, like square root of 2.
Absolutely.
Anything.
Anything. Yeah, that's all what it is. Now, imagine the universe has no beginning and no end. If the universe has no beginning and no end, every combination of atom, every combination of matter will exist, re-exist, and exist and re-exist. And that is actually the theory of multiverse. There are 4 different levels of multiverses. Do you know what they are?
No.
Well, there is a so-called the geographic multiverse, meaning that there's only, let's say, our universe, observable universe, is made of so many atoms, so many even basic structure, quarks, fundamentals of matter. They can exist in so many combinations. Okay? But if the universe is infinite, even in this universe, when you get far away, that same combination of quarks, which makes you, must exist. It's so far away from us because you can calculate actually the statistical possibility of what that would be. Like you calculate how many quarks are in our observable universe, how many combinations can they exist of them, and you calculate how many times do you have to have that amount of matter to have any combination. It is, again, mind-boggling big. But if the universe is infinite, that must exist. Now, we say universe is 13.7 billion years old, and it's about 95 billion light years. But by the way, how can it be that the universe is 13.7 billion years old, but the size of the universe is from one end to another is 95 billion years? How can a universe that is 13.7 billion years is 95 billion years from light years from one end to another?
Because light traveled in different distances?
No, but even if
in different directions.
But even in different direction, it should be 13
billion or 30 billion?
13, 1, 3.
13.
Yeah, should be 26, right?
Means the shape of universe is not defined as a plane or something.
No,
or a sphere.
It's very easy, actually. You remember we talked about universe expanding?
Yeah.
Even though the universe, the Big Bang was 13.7 billion years, but since then, universe has been traveling faster than light. Nothing can travel faster than light, but the space itself can expand faster than light. And that's exactly what Hubble found out, okay? That some universes are so far that probably we will never see them, and its relationship to how fast they are going away from us is depending on how fast they are from us already, meaning that space is expanding at certain rate. That certain rate, if you calculate it, after 13.7, 14 billion years, those universes that are there, they're expanding faster than the speed of light, so we can never see their lights. That is why we can see only 13.7 billion years. Anything beyond that is moving away from us, and it's getting better. There are lots of galaxies that are 13 billion years away from us. Soon, they will be behind that wall. So it'll be in maybe 100 billion years, the sky will be just or the Milky Way galaxy. We won't be able to see any other galaxies at all. So it's a very interesting time in human history that we see all these other galaxies. We see the birth, we see the background radiation. We know about the future astronomers. If they don't know about our findings, they wouldn't be able to calculate the Big Bang because they wouldn't see any of that. This is all just prelude. This is foreplay. We haven't talked about the Boltzmann and Poincare and so on. Now, once you know the story, the history behind that, and all of that was far before Einstein or Hubble existed and so on. Eventually, we found out that matter behaves in a certain way. Especially, that was all interesting to build something really practical, steam engine. And especially in England and in France, it's a nice story behind that as well. First, the British, they developed the steam engine, and they were militarily so strong, and they won against French. And then in the French, they was like, we are staying behind the science. We have to keep up with the British. So they put a lot of effort on that. And Poincare was the child of that movement. Boltzmann was a German, at that time, Germany, to sense of today, didn't exist. But they were scientifically very high. Calculated how heat disperses. Okay, he found out and he calculated, like, you have this room we are here right now. You create a hot pocket of air here. How would this hot pocket of air distribute itself in the whole room? Now we know, like, you pour like a hot water in a cold water. Eventually, all of that become one temperature, right?
Yes.
How do you know that? From experience, right? It is one, when you pour it in, one is cold, one is hot. Eventually, everything is the same temperature. And if you mix it with the hand, with finger, it's faster. That is why, same thing, if you mix milk with your coffee, eventually everything becomes the same. How does that work? Even if you just pour the milk in the coffee and do nothing, eventually everything will be at the same consistency. How does that work? At that time, they didn't even know the atom exists. Isn't that interesting? They did not know of the existence of atom, but they could calculate how heat disperses. Hence, thermodynamics. It's the most sweet when you go on and understand the basic of it. And that was practical because they were trying to build heat and steam engines. You have to know that so you don't do your steam power engine wouldn't explode, or you get the maximum thing out of it. And they became good at it without understanding anything about atoms. Now, let's go one further. Boltzmann and some others, they found out that there is a relationship about how cold the rest of the room is, how hot the air is that you put here. There is a relationship, how this disperses. And they found out, like, when you put milk in a coffee, it always goes one way. The milk and coffee come together, they become a homogeneous thing, but it never, ever, that becomes that coffee and milk separate. But why? Why would coffee because we knew about the laws of nature, we knew about the Isaac Newton's laws and so on. Every law in the universe is reversible. But in reality, we always see milk dispersed in the coffee, but we never see milk.
Like coffee milk come back into a droplet.
Yeah. The milk in the coffee does never come back to the droplet. But why?
If you're given enough time.
But that's the point. That is the point that we are going to make.
Yeah.
Don't steal the end point. But have you ever seen milk coming back?
No,
You have never seen that.
no. Nor does in a room where a pocket of hot air just form out of nowhere.
And that is the whole idea of entropy.
Mhm.
Okay. The idea of entropy says that everything becomes homogeneous and disorganized.
Mhm.
Like, let me use an example of that I just made a TikTok not long ago about understanding the entropy. Okay.
Yeah, the like the milk or hot air.
Yeah, but now, like, everything. Let ask you a question. I think you probably know that, but many people may not know that. We get our energy from sun, right?
Yep.
And the sun is something that we call very low entropy. Lots of energy concentrated. And it gives Earth energy, right?
Yep.
How much of the energy of the sun does Earth reflect back to space? 80%?
80 or more, a lot.
Well, so we get this energy from sun and we reflect it back to the rest of the space, right?
Yep.
What would you say? Give me a number.
Like the percentage?
Yeah. How
I'd
much
say
of that
like-
do we reflect back?
Like 90%. Like a lot. Like we are not efficient at all
So let me ask you that.
with what we're
If,
given.
if we would keep 10% of the energy of the sun, what would happen to Earth?
I don't know,
We
very
reflect-
advanced.
We reflect 100% of the energy of the sun back to space. Because if we wouldn't, Earth would get hotter and hotter and hotter and hotter, melt, vaporize, and so on and so forth, right?
No, because things we're using today is powered by the sun.
So then let's go back to the thermodynamic, the first law of the thermodynamic now.
Okay.
Energy doesn't
Get created nor disappear.
nor disappears. Imagine day after day, we would keep 10% of the energy of the sun in Earth.
No, that's too much. What I mean is like the sun gives energy to plants and animals eat them and dies and become petroleum. That's how they
Yes, but then
that's how energy
but
of the sun stored. in
stored.
Earth.
But how much of the energy that we get from the sun do we send back to space?
A lot. Like why would it be 100%?
Because if it was anything but 100%, our temperature would be infinite. If you would keep any of the energy of the sun on Earth over the last 4.5 billion years.
So where does the energy of your gas come from?
So energy of what?
Of your gas, like inside your car, the gas inside your car.
That,
Where
it does
that
come from sun, but
Yeah, right.
you see that there? That is the mistake. That is the when you understand thermodynamic, to understand Poincare recurrence theorem, you have to understand what that really means. Okay, so simple math. You're a mathematician.
Sort of.
Okay, so you get over 4.5 billion years certain amount of energy from the sun. You keep 0.00001% of it. What will happen over the 4.5 billion years history of Earth?
Like the sun emit a vast amount of energy. Like the sun, the Earth.
Just talk about the Earth. Let's talk about only the Earth.
The Earth will heat up a lot. Like how am I storing the energy in form of
I will
what?
come back to that. I just want you to first admit, to understand why we have to emit the 100% of the energy we get from the sun back to the space. Because without that, you have to admit if that energy accumulates.
Yeah, it will be infinite. Like
So you understand that now,
yes,
right?
Yes, I do.
You understand that there is no other formula that you can bring up except that we get sent back to a space, 100% of the energy get, but still we get a lot of usable energy out of it. But how is that?
Yeah.
So, and that comes entropy. We don't use energy of the sun, we use the organization, we disperse, we exponentially use the energy of the sun and they create entropy. And let me tell you how. So sun, what is the energy of the sun we get? What wavelengths we get? We get high, infrared, the ultraviolet, we get high energy photons. And then what do we emit out? We emit infrared, right?
Yeah.
For every photon we get from sun, we emit 20 back to space. But those photons that we emit back, they have the same amount of energy, but they are literally lower wavelengths.
Okay. Yeah.
And that's what entropy is, meaning that we take high level of energy, we created too many and much more lower level of energy at the level that is not usable for us anymore. The only thing that we use is not the energy, but the gradient in the energy. That is what we use. That is entire life is made of. Okay, so meaning that you had hot pocket of air here. That hot pocket of air has higher pressure.
Yes.
So if you contain that hot air in a box and you put a turbine in that box against the rest of the room here, that hot pocket of air pushes out and turns the turbine. But once inside and outside of this room are in this box are the same temperature, the turbine stopped working. That turbine is life, it's us. We get the hot, higher level of energy of the sun, we store it, we use it, we become alive, and then that becomes lower level of energy and dispersed in the rest of the universe. And that is entropy. Entropy is practically the gradient in the energy level of two medium that you can usable now. And that all makes sense, right?
Yeah.
Except statistically, based on laws of the universe, if you let this room long enough, and that is what Boltzmann did, eventually that hot pocket of air will again come back here if you wait just long enough. But why do we see, and that's the question now, why do we see so often the hot pocket of, let's go back to the coffee and milk. Why do we see so often that the milk disperses, but we never see the other way? Why is that? Did you ever think about that?
Because we don't observe that long enough before it starts to spoil.
That is actually the exact reason for that, because so let me explain to you the entropy in a different way. Why egg breaks, but broken eggs never become an egg? Why milk disperses itself in coffee, but never the other way happens?
Yeah.
Imagine you buy a deck of cards, right?
Yep.
When you buy the deck of cards, they're all well organized.
Yes.
1 through
From
the
base to
10
king.
and so on.
Yep.
One color after another, one group after another. Okay, it is organized. So throw all those cards in the air and then gather them together. What is the chance that they are still the same?
1 in 48 million.
Good one. but so what that mean? You have to throw it. Actually, it's much more than. I think it's much more than that.
I think it's 48 million.
1 in 48 million. I think it's significantly more than that. You want to calculate it? You have your thing? So it is 40. How many cards are they?
So
Are
about
about
13 times 4, 52.
52. It's 52 factorial.
Yeah.
52 factorial is way more than that.
Really?
Calculate that. Yeah.
Let's see.
52 factorial.
What is 52 factorial?
It should be billion, trillion.
Yeah, it's like 8 to this 8 point to the E67.
67.
So
You
that's
see,
way more than 48.
way more than, it's like almost halfway to Google. No, not even halfway, not halfway to Google, but it's way more than that. So, meaning that if you throw it up in the air and gather them together, there is way more being disorderly than orderly.
Yes.
But if you throw it, you just calculate that. If you throw it often enough in the air, eventually you throw it up when you come back together, it's exactly the same way it is.
What is a throw? What is a shuffle in the coffee case? The
Well,
passage of time?
No, but no. We are talking about now, let's talk about the cards,
Yeah,
because
okay.
that's 52 cards, that's calculable,
Yep.
right?
Yep.
So you throw the cards up, gather them. You throw the cards up, gather them. Once you have done it 8 to the power of 67, and then more than that, and more than that, then it's likely that you have one condition that those 52 come exactly in the same order.
Yep.
The reason you never see that, because that is so, there is so many more ways of them to be disorganized and organized. Now, and that is just with 52 cards. Now imagine all the molecules in the coffee and the droplet of milk.
Yep.
So you see, it is, but statistically, if universe is without the end, if there is no beginning and no end to the universe, that will eventually happen.
Yep.
Now, Boltzmann wanted to trick the thermodynamic. He created this Gedanken experiment or thought experiment called Boltzmann or demon, and after him they called it Boltzmann demon. Imagine we divide this room in half, and there is a gate there, and there is a demon sitting up there, and wait, and just there is a gate there. Every time a hot molecule comes, he opens the gate. But if the cold molecule comes from one side to another, he closes the gate. So he selects consciously for faster, hotter molecule. And then eventually one side will be much, much hotter because the Boltzmann demon opened only the gate when the faster, hotter molecule coming toward the gate from one side to another. Then all of a sudden you have reversed the second law of thermodynamics, theoretically. And he thought he has tricked, at least in a Gedanken experiment, in a thought experiment, he has tricked the second law of thermodynamics. Yet, if doesn't matter how beautiful your thing is, if it's against the second law of thermodynamics, is doomed.
What's
Why?
the second law again?
That the entropy goes from
low
entropy to high entropy.
From order to disorder. Okay.
From order to disorder. Okay. So the first law is energy doesn't get created or it doesn't get destroyed. It just converts. And second is high order to low order. So why that thing wouldn't work? Why is that demon that watches every molecule that moves around and just opens up and just let the hot part go to one side? Why that really wouldn't work? Because amount of the information you need to calculate for that is that itself adds to disorder. That demon need energy to do that. You need energy to open the gate and close it. So that really it doesn't matter how small and so on it is, even it's just a single atom energy and so on to open and close the door, just that demon and the gate still disperse the entropy, increase the entropy. So we have local phenomenon of entropy increasing like on Earth. Life, that's what life is. Life make the disorder to order. But for that, you need a local, bigger source of energy that so the sun gives us so much higher level of order, and we use some of that to create order, and then like the sewage is all the infrared radiation that we throw up back to space. It is like you're using the pressure of water for your reverse osmosis. You know, all the reverse osmosis, they use the pressure of water, and then they dump that water back to press more water through the diaphragm and create good, better water. Or other example for that could be that, you know, you use practically use only a part of the energy to create order. But overall, it always goes from order to disorder.
Like if you clean your room with a vacuum cleaner, the
Yeah.
room is cleaner, but your trash can is more disordered.
Very good example. But yeah, at the end of the day, you're always going to create more disorder than order, but you can have local order, and that's what life is. Now, let's come back to recurrence theory, okay? That if you wait long enough, that milk separate itself from the coffee. But that's just going to be, you remember with 52 cards, it was...
Yeah, like 8 times 10 to the 67 power.
So now imagine you have like all these molecules there and so on, unimaginable number of molecules. You can imagine, you know, how many shuffles would that take to get that back. But imagine like pi, if there is no end and beginning to that, that must, not only that can happen, that must happen. And that must happen indefinite amount of time. And yet, we never see that because our lifespan is so short, but that is the beautiful part of it. Recurrence theory, meaning that statistically, based on everything we just talked about, that every condition recreate itself again and again and again. So there will be, you remember we talked about the different levels of universe, multiverse. Now we are talking about the second kind of, the first level of multiverse, the space is so big and the atoms and so on can have only this many conditions. So version of you will exist you know, beyond our horizon at some place. Now, this is the second kind of multiverse that if the universe have no beginning and no end, and it just goes on and on and on, eventually those atoms come again, exist. Somebody like you with your thoughts eventually statistically must exist, has existed in the past. There's no reason to believe you are the first one, and must exist in the future. So, and you want to call it a reincarnation, call it whatever you want. It is a consequence of understanding the math and physics of it. But that wouldn't work if the universe has a beginning and end. This would work only if the universe doesn't have a beginning and doesn't have an end. This beginning and end is the just thing that we can see or calculate, but there must be something beyond that. You understand that, right?
Yes.
If the pi had a limit, that wouldn't make sense that every story would exist in it, okay?
Okay.
So, because the statistically is so rare, so how do we solve that though? How do we solve that idea that universe doesn't have a beginning and doesn't have an end? Because we just talked about that. If you run the clock backward to Big Bang, that is a beginning. And if you run it in the future to Big Chill, everything falls apart and universe becomes dark and empty. How are we going to solve that problem? If we don't solve that problem, your reincarnation is just
like
becomes nonsensical.
Like that goes back to my question. Like if you shuffle a card, there is an act of shuffling. But in the case of coffee, like there is no case of shuffling. You just let it run.
Brownian motion, no, Brownian motion, that's shuffling, it shuffles itself. Every molecule there has a Brownian motion.
Like,
and then
let's suppose we throw a deck of cards in the air and it's on the floor and you do nothing.
Okay.
It's not going to come back together, right?
If you wait long enough, it will.
the car will come back together.
Yeah, that is the, see, you're thinking about the macroscopic kind of phenomenon, okay? And you always think something has to bring them together. I'm talking about at the fundamental level of the molecules and so on. Every molecule moves in certain way.
Yeah.
Okay. Now, we cannot even fathom that the cards come together by themselves, but even make it easier. You throw it up, they all come back together in a deck of cards that it is just assembled. What about that?
Well, it could happen.
That is more likely to happen than all of them come together.
Yeah.
It's more likely that they come together as a deck of cards than they come together in the right order. Because the coming in the right order, we looked at what the chance of that is.
Yeah.
Okay, so don't look at the macroscopic human experience kind of it. Look at it mathematically. So if universe has a beginning and has an end, reincarnation becomes nonsensical. Because statistically, it is so, considering how many things we have, how many possibilities we have, that it's become nonsensical. For that to make sense, universe has to be cyclical or eternal. By the way, there are two other kind of multiverse that I'm not going to mention here, but if you're interested in that, if you're interested in the other ways of universe, the most interesting part is from whoever who calculated the quantum mechanic and the Heisenberg theory and found out every time you decide on something else, a new universe is created. Crazy math, okay? So, but if you're interested, go read about whoever okay? But let's not go there. Let's stay with that. How do we solve the problem of cyclical universe or eternal universe? That Big Bang was in the beginning and Big Chill is not the end.
So, like, you mean after the Big Chill, there is another Big Bang? It will contract? No?
Well, mathematically, I know. So, now, what is the characteristic of black hole?
It has great mass and a singularity, and that's all I know.
Yeah. So the characteristic of black hole is that has infinite density to a point that light cannot escape from it. For a long, and we can never see inside of a black hole because no information can come out of it. It has actually two characteristics only though, mass and spin.
Spin.
Yes. Black hole has a spin, and these two is enough for us to make some mathematical physical calculation about black hole's behavior, how it's going to behave, just these two. And the math of it works that way that when you fall in the black hole, closer you get to the singularity, the time and space, we talk about space-time. You want to explain what you understand under space-time?
Like space-time.
What is space-time?
I don't know what a space-time is. I know what a space is. I know it can be bent.
Yeah.
So that your experience like may differ from other depending on like how big the gravity is around you.
Where are you right now?
Earth. North America, Minnesota.
I can give you your GPS right now, right?
Yeah, like a coordinate.
Yeah. So for anything to happen, you need a space coordinate and the time coordinate. Like you weren't on this chair 3 hours ago.
No.
And you won't be on this chair in 2 hours.
No.
Everything that happens in a space and in a time. Like, you know, if you and I are going to meet, I tell you, meet me in that restaurant at 5 p.m. If you go 6 p.m., I won't be there. If you go 4 p.m., I won't be there. If you go to a different restaurant, I won't be there. You need a space and the time. That simple it is. For everything that happens in the space and the time. But it took us a long time to understand that these are related. You can move fast in space or fast in time. But if you move faster in one, you're moving slower in the other. We thought, based on Isaac Newton, these are independent things. You can, time is constant, and you just move in space. We found out that is wrong, wrong, wrong. These are totally related. If you move faster in time, if you move faster in space, you're moving slower in time and vice versa. Einstein theory. That's the fundamental of Einstein theories, okay? And this coordination of space and time, we call it now space-time. 3 space dimension and 1 time dimension. If you move faster in one, you're moving slower in the other and vice versa. There's a certain amount, it's a vector. You can, nothing really stays still, but let's say you're staying still, all your motion will be in time. And for that reason, if you put all your motion in time, your mass become infinite, because there is nothing, no space anymore. All your mass become infinite. Does that sound familiar to black hole?
Yeah, it's very big density, very big mass.
Very big density, very big mass, infinite density. But black hole doesn't move, right? Black hole is not. So, Einstein, the formula regarding the motion and so on, that when you time dilation, right? You move, like if you move like 90% of the speed of light, you have like your 1 second is like, for me, is almost 1.7 and so on. If you're 99% of the speed of light, your 1 second is like my 2.5. If you are 99.9% of the speed of light, your 1 second is my 5 second or 5 minutes or whatever. There's a formula, you can calculate that, right?
Yep. Like you just said, when you move faster in space, you move slower in time.
Yeah. Now, the density is infinite in black hole. Space loses its meaning, yet black hole is not moving. So the calculation of that is as such that when you get to a black hole, space and time, they change. What you consider as time becomes space, what you consider as space becomes time. When you physically move in black hole, you're moving in time. You remember that movie Interstellar?
Yeah.
When he was in that inside of the black hole, he was moving, and when he was moving from one place to another, he was at different time in the library where he was meeting his
daughter.
Yeah, that is based on that. Based on this, that in the black hole, most likely it converts a physical movement in the black hole. It becomes a time movement and not space movement, because they switch. So hold that thought for a second, okay? Second thought. It's getting interesting, right?
Yeah, it is.
And you thought that we are just going to talk about Poincare resurgent and the reincarnation, but we have to solve the mathematical problem of it to get there.
Yeah.
Okay. What are the states of matter?
Solid, liquid, gas, plasma.
Okay, let's start with plasma. What is plasma?
Usually people start with easier things.
Okay, well,
all right, let's start with plasma.
No, everybody understands solid, liquid, gas, right? So let's start with plasma. What's plasma?
I don't know, but I know maybe fire is the plasma.
Well, when you knock out all the electrons of a molecule or atom, it's a pure, the molecule atom without any electron, that is called plasma.
Oh, okay.
Okay, the plasma cutter, we use it all the time. Do you know how it works? You put the air through an electric arc, and then that air loses all its electron. It becomes so reactive. It eats everything it comes to contact, because it just sucks out all the electron from whatever it comes to contact. Plasma cutter. I have one in my garage.
For what?
Don't
For-
ask.
Do you use it in surgery?
No, I don't use
No.
that in surgery. Now, and there are some other higher level energy state of matter. Let's go to the other side. Is the solid the on the cold side, is that the only kind of state of matter we have?
Maybe not. No, like when like what
Have
do
you
you
heard
mean
like
by-
have you heard like metallic hydrogen?
no.
So then when in the center of sun the pressure is so high, the hydrogen, which is a gas, is not liquid anymore, is not solid anymore. It behaves like a metal. It becomes a metal, not it behaves like a metal. It's a very special state of the matter. And that is lots of
Superconducting?
Huh?
Superconductors?
no, well, this is I'm talking about, still higher level of energy. No. When now you cool these things, the material, the molecule, the atom, an electron in a matter, they behave in a different way. All of a sudden, when at certain temperature, you lose any friction, and the electron, they just fly through it with no resistance. That is the superconductivity. Okay. If it's a state of matter, we are not sure about that. But I would call it a state of matter. But let's go even colder. How much colder? Like 0.
Kelvin?
No, you never can reach 0 Kelvin. It's impossible. It's like a speed of light. You can never reach 0 Kelvin. But let's say like 0.00002 or 3 Kelvin.
Okay.
And you do it for something very special. You do it for a helium atom because we have observed that. We know how it behaves. All of a sudden, helium just penetrate through the wall of the things. All of a sudden, helium behaves like a wave. It has no friction. It just flows everywhere. And if you look at it, like they have achieved that with like so very minute amount of helium. But once you reach that temperature, that low temperature, the whole molecules became one. The whole atom become one. It's not like individual helium atom. It is all of that is just one atom. Let me repeat that in a language that we understand. If we cool you and I to that temperature, you and I will become one.
One molecule?
We become one atom. We become one whatever. We will be undistinguishable. If we cool you and I here right now to that temperature, first we will die, but then we will become truly one. Think about that for a second. Once you cool that close to the 0 degree, all of a sudden you stop existing as different entities. Everything become one.
Okay.
Independent of how far we are from each other. If you and I are the only thing that exists in the universe, whole universe, and if we are cooled down to that temperature, there's a new state of matter. Do you know what it's called?
No.
It's called Bose-Einstein condensate.
Oh, I heard of it.
Yeah.
In another language.
Yeah.
Yeah.
So almost is metaphysical, almost is theological. Doesn't matter where we are in the whole universe. If there's nothing else there to interfere with that, and you cool us down, our wavelengths become one, we become in synchrony, we became one. Let's go to Big Chill now.
Yeah.
The Big Chill is everything has expanded, if space has expanded, and everything has cooled down. and becoming closer and closer to absolute zero. The space is all what it is. And you remember we talked about that? Cosmological constant, Einstein's biggest blunder. Cosmological constant says empty space has energy. So empty space is not really empty. This virtual particle come and go, and it is not empty, that's energy. No, you cool it all down, close to absolute zero. This is my theory now, okay? That once you get that cool, the whole universe to absolute zero, the whole universe becomes one. And when the whole universe becomes one and space become irrelevant, it switches. Then you have the same condition as inside of a black hole and inside of a Big Bang. Because space doesn't matter anymore. Once everything is cooled down, the whole universe, we talked about that space is something that can become irrelevant, like in black hole. Space-time is just one versus another. Now everything has practically what it is. Energy and matter are EMC squared, right? Energy and matter are convertible. And the entire energy of entire matter in the universe turns to energy, and the entire energy in the universe turns into space. But all of a sudden, when they cool down enough, all of that become one. And universe start again. It is no different than you imagine, that, and eventually you see that there is no need for any higher power there and so on. It is just a fundamental nature of the space-time that everything is expanding, everything will fall apart, matter become energy, energy become lower level, and it turns into space. Space is expanding and so on. And I'm not going to go talk about dark energy and dark matter at all, but space, everything is space, and space has a certain level of energy itself. And now it has all the characteristic of Bose-Einstein condensate, and all that matter, the space, all of a sudden, boom, space is gone, everything is there again, then you have maximum order again.
The Big Bang.
You have another Big Bang. For that reason, lots of people say on the other side of a black hole is a Big Bang, is a white hole. That everything on the other side is spilling out, becomes another universe, and so on and so forth. That would give eternal cyclical universe a meaning. That would make all that statistic that we talked about give it a meaning.
Yes.
And that makes the Poincare recurrence theorem, that makes it not only possible, but practicable and real. So you can hope that the version of you will exist sometimes in the future if this is true. Lots of speculation, obviously, lots of theory there. But this is the thought process that truly can exist. The milk will gather together one day. Your molecule and quarks and atom, they will gather one day together, give another. This conversation will happen again and again and again.
But yeah, just like last time we talked about chaos theory, a slight change in the starting state will result in unimaginable chaos in the future. When the Big Bang, as you call, happened again, like the initial state is different than what happened last time.
Yes,
right?
yes. The possibility that it will happen at the same time is so low that it happens all the same, but it repeats itself in infinite time. And that is the point. That is the whole idea. Try to find your story in pi. You can't. But theoretically, you will be if your life is not long enough, your time is not long enough, but it is no question. If time is the only thing you have to prove here, that the time is infinite, or not the time, the universe is infinite, because time is itself, that is a factor there. Okay, but that the universe is cyclical and infinite, that gives all of the recurrence a meaning, a possibility, and it's all about then all become about statistic.
Yes.
Okay, so if your pet is not smoking yet, I would recommend you go and listen to this one more time, because my head smokes every time I do think about this.
Mm.
Now, we don't have to be, really theologic about it or metaphysical about it. The idea of, reincarnation and so on. Certainly, we want always to believe that there's a meaning and we always come back and so on and so forth. This is all theory. We can as well, think about this, but when it comes to our action, we can live today, this year, and do the good today without thinking about if I'm going to exist again or not. But these are the ideas that we talked about. These are theories we talked about, but these are not brain thoughts. Biggest minds in the world have thought about that, like Poincare and Boltzmann. And I always get excitement about reading about their work, their life. It's actually that if you want to go read about this stuff, don't read just about, Boltzmann theory or statistical thing. Go read about their lives and how they came with this. Like each of them, they had their own demon, they had their own bad stories and so on. Their life there are people with lots of interesting stories. Go read about them. And there are lots of books out there that I think you can enjoy reading about how they came up with all of this. Okay, so it has been long enough. Misha, what else should we talk about before we close this session?
Maybe some expectation for next time. Maybe next time we can talk about some critiques of this theorem, because it's a theorem.
Yeah, obviously, obviously it's not. I mean, there's no way for us to prove that. But we should definitely put it on a path to talk about some other theories and so on. Like now, and as well, maybe that's a little too much heavy in nature for lots of people who listen to that. But the thermodynamic, the rules of thermodynamic, and what they really mean in practical life for us. Okay, and it makes so sense that. Well, did you know that if you know thermodynamic, you can save on your gas?
What?
And even on your car, on your gas. If you know that, you know exactly how to save your. How
do you save your gas?
That I stop giving gas about the half a mile before I have my exit, and I let the car just roll up.
Yeah, like
and use the energy, the potential energy. The kinetic energy create potential energy when I'm going up the ramp.
Yeah, like for me, it's brake as few brakes as possible.
Because that heat goes to
friction.
That energy goes to the heat to the brake pad.
Yep.
Whereas if you stop giving gas when you have to go the ramp up, your kinetic energy become
that's interesting.
Potential energy.
That's interesting.
Yeah. Well, so that can save you money and time. Okay. Okay, well, anything else, Misha?
I think we're good. We had a really productive discussion. Thank you, everyone, for your attention.
Well, I hope, you can still keep up with us, but lack of our Amanda, I hope you enjoyed this episode of Essence of Science, Poincare Recurrence Theorem. The theorem itself is easy, that everything that ever have existed come and exist again or close to it. But the background of that, you cannot imagine that if you don't know the background. And I tried to put the background of it on the table.
Did a good job.
Well, thank you very much for joining us.
I'm Misha. Have a good night.
And I'm Dr. Abbasi for